going to blend. What you're used to with graphs is x, y, right? So on a graph, you'd go over x, up y, and you'd plot a line. We did parabolas and all that. But what we're going to do a little differently is that in the x are going to be the radians in the x. Y is still y coordinates, just as it always is. Nothing new there. So you have your radians, you have your coordinates. Okay, now let's plot a couple of these. So here's 0 degrees, and the coordinate at 0 degrees is 1, 0. So the x value is 1, and the y value is 0. Now we're going to do sine. Which was sine, the x or the y? The y. So I like to start with this one. Start with 0. Now, when we get over to pi over 2, the coordinate looks like this, 0, 1. So now the y is 1. So at pi over 2, the y is 1. At pi all right, at pi, the coordinate is negative 1, 0. So now the y is back to 0 again. And then at 3 pi over 2, the coordinate is 0, negative 1. The y is now negative 1. And then where is it back at 2 pi? 0. So if you connect the dots like that, you get the sine curve. So there's your sine. It is a portrayal of the y values of unit circle, where the x is the arc length and the y is the y value. Goes up to 1, goes down to negative 1. Make sense? Okay, now look at this. This is what it's doing, right? But what if I move a little bit to the left as I'm doing that? Watch that again. So I'm going like this, up and down, and then I move to the left. See how it's just up and down movement shoved in time, or in this case in space. So you can see that. All right, so that's the sine of x. Now, wouldn't it be magical if I could just show you magically what's happening to the cosine? Scroll down. I can do that. Now, what's happening to cosine is we're looking at the x values. So in the first part, we said sine of x were the y values of the unit circle. This, obviously, cosine are the x values of the unit circle. Okay, so x starts out at 1. So at 0, we're at 1. At pi over 2, what were we at for x? 0. And then at pi, I was at negative 1. At 3 pi over 2, I'm back to 0. And then at 2 pi, we're back over to x equal to 1. So as this one is drawn, it's going to look like that. That's what's happening to the x. Now, we wouldn't graph it that way. We'd graph it turn 90 degrees. But if you turn your head, can you see the sine curve? Or cosine curve? That's cosine. So in review here, if I ask you to draw the sine curve, y equals sine x, here's what you'll do. The sine of 0 is 0. So you start at 0, you go up, down, and up, 0, 2 pi, pi. You go up to 1, you go down to negative 1. For cosine, what's the cosine of 0? It's not 0. Cosine of 0 is what? 1. So it's out here. So here's your 1. This one goes down, comes back up. So here's 0, pi, and 2 pi. And there's your sketch of cosine. You're going to have these memorized by Friday, because this is going to be a quiz on basic trig graphs on Friday. These are the only two you have to have memorized. Sound good? So that's sine and cosine. What we're going to do is we're going to blow, well, here, a couple things to say about sine x. Sine x goes forever. It goes forever, but we're only usually just drawing one period of it, one cycle. But it repeats. You see how this purple is the same as the blue, and the same if we went back. Purple is the same as blue. So it just keeps repeating after this. If you show the pattern, it doesn't stop here. It goes in both ways. Want to see something really cool? Yeah. So here is the sine curve. Sine curve, right? Here is the cosine curve. Here's the cosine curve, right? What do you notice about that? How far did I shift it? 90 degrees. You mean to tell me that the cosine of pi over 2 minus theta is the sine of theta? Right? I showed you that a couple minutes ago. All right, love that. A little extra thing. We'll talk about all that a little later. Now, this is the part that you need to focus on the most. When we're sketching graphs, there's usually going to be some changes to it. I'm not going to ask you to draw the sine of x or the cosine of x. I'm going to ask you to do a wide range of other things. The wide range of other things could take place as an amplitude, a period, and a phase shift. When I've taught this in the past, this is 1 day each. We're doing it all in 1 day. So I hope you appreciate how we're putting these concepts together. So the amplitude is the vertical stretch of the sine curve. So if, in this case, A is the value in front of multiplied by sine, 4 here is B. This is the number multiplied by theta in the function. In function, outside function. If it's inside the function, it's going to have a whole different array of other things that we're going to be doing. But if it's outside the function, all you have to do is say, oh, that's the vertical stretch. So I'm going to draw a sine curve. Would you do that as well? How high does the normal sine curve go? Up to and down to what? What do you think, Lena? How high does this one go? 1 and negative 1. What do you think it does when you say 3 sine? 3 and negative 3. Isn't that easy? That's the amplitude. That's how high it gets stretched out. If you are at a rock concert, this is the amplitude of the wave, how loud it is. Okay. The number inside is going to be the affecting the period. Now, I like to explain it this way. Normally, the period is 2 pi, right? But this number B tells me how many periods there are, periods or cycles, between 0 and 2 pi. So how many is this saying there are? 4. So I can make 4 of these. I don't even know if I can. 1, 2, 3, 4. There you go. I made 4 cycles. Now, we will want to know what 1 period is. So what will 1 period be if 2 pi has 4 of them, what will one period have? Pi over 2. It'll have a fourth of 2 pi. Exactly. So what you do is normally we have 2 pi, and the b, in this case 4, is what you divide by to find out what the period will be. So for this one, the period is going to be, and I like to write it out, 2 pi over b. In this case, it's 4, which will be pi over 2. So what do? Here's what I do. I draw this whoosh, sine curve. Normally 2 pi, but this one has a period of what? Pi over 2. And then in the middle, if you would, write pi over 4. It'll be helpful later. So there is, ta-da, 3 sine 4 theta. You sketched it out perfect. You don't use a calculator. You can just sketch these out. Let's see. Let's keep going. Phase shift. All right. So for the phase shift, we're going to get to that. My main thing is we're going to factor out first. Factor out first. Hey, we're doing great. Let's do a couple of these. We'll do this one together. 4/5 cosine of pi times theta. So what is A and what is B? What should we say A is? Number in front of cosine outside is? A little louder. A little louder. There you go, 4/5. Nathan, what will the amplitude be then? Well, the amplitude is just whatever A is, 4/5. That's okay. What's B going to be, Nathan? There you go, pi. So this sounds really horrible, doesn't it? Pi for a B. But look what happens when we take 2 pi over B. 2 pi over the number of cycles here. 2 pi over pi, what's that going to be? A period of 2. This is kind of neat. By the way, there is no theta minus, so this is 0. There's no up and down, so this is 0. These two are both 0. So is the cosine of 0 0 or 1? Cosine of 0. 1. So we start up here, go down, make your 1 cycle. And you know there's cycles go forever, but we're just doing 1. The amplitude is 4/5, negative 4/5. And 1 complete cycle is 2, put a mark in the middle, 1. If you wanted to, this would be a half. If you wanted to, this would be a fourth. But that's all you need for 4/5 cosine pi theta. Amazing. Here's a tougher one. Now what we're going to do is we're going to deal with a plus and minus inside the function. Now the first thing you're going to do, you are not going to do anything yet. You're going to take out a 2 first. Because when I factor out the 2, I'm going to have theta plus or minus something. Okay? So when you're trying to figure out what's factored out here, I like to do this. 2 times box is equal to pi over 6. That makes sense? I'm taking out a 2. I'm pulling the 2 out. It's going to be plus, but I'm going to solve for box. So what's box going to be equal to? Pi over what? 12, right? Did I do that too fast? Double check. Is 2 times pi over 12 pi over 6? Okay. This is just a little helpful thing, is I'm factoring out a 2, so I'm factoring out a 2 times something is going to be equal to pi over 6. You can see it very easily. You divide by 2, you get pi over 12. Okay, now, this is my A. This is my B. This is C. D is 0 again. I'm going to put a 0 there. A was 12. B is 2. C is going to be pi over 12. So the amplitude is just what, Emily? 12. The period is 2 pi, is a normal cycle. Divide by 2, we're going to get pi. That's good. And then the horizontal shift is whatever is here. Remember x minus 2 squared equals y? What did that do to the parabola? Which way did it move it? Left or right? Right, correct? Because a 2 is going to make this 0. What if I had a plus here? What would happen? Then it would move to the left, 2, right? So plus means to the left because negative 2 will make that 0. Minus means to the right. It means the exact same thing with sign. So if I have a plus here, then what is that going to do? Move it to the right or to the left, pi over 12? To the left. Would you write that in, please? And there's no vertical shift. Here's how I do it. You can do it other ways if you want, but I like to do it this way. Draw the sine of theta. There's your sine curve. Sine of 0 is 0. It goes up to 12, down to negative 12. One complete cycle is pi. Let's make this blue. Half of that is pi over 2. Half of that is pi over 4. Half of that is pi over 8. Half of that is pi over 16. Now, why in the world did I do that? Well, because we're going to shift this pi over 12, which is a little more than pi over 16. It's going to be about that much. That's good enough for that shift. All done. Help with that. Just to speed things along, we're going to do A, B, C, and D. A is what for this one? What's in front of cosine? 2/3. Now, before you do anything, would you please factor out, oh, there's a negative in there too? Oh, let's just make this a plus for me. Just change that to a plus. I'm not ready to teach the negatives yet. So you have 2/3 cosine 4, and then it's going to be x plus something. The x plus something is going to be 4 times box is equal to pi over 2. So what will box be? Pi over what? So pi over 8, yeah. Good. Okay, so then this is my A. This is my B. This is C. And then D is still 0. Oh, no, it isn't in this one. What is it? Aha! It's 1, because there's a 1 out here. Yay, we finally get a D. So B is 4. The period is 2 pi over 4, which is pi over what? 2. And C is pi over 8. And because it's plus, is that left or right? Left. Good. And then D is 1. Is that plus 1 going up or plus 1 going down? Up. Perfect. Okay, so the cosine of 0 is 1, so I'm going to just go here, 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 and here. It's a very terrible cosine curve, but it'll have to do. We're going to go up to 2/3, down to negative 2/3. 1 complete cycle here is pi over 2. Half of that is pi over 4. Half of that is pi over 8. Then when I draw my curve here, I'm going to shove it to the left what? Pi over 8 to the left. So it's going to go like that. And then I'm going to do one more thing. What is that? I've moved it to the left pi over 8, and I'm going to move it up 1. So this is going to go, here's 2/3, here's 1/3. It's going to look something like that. And that's the curve. And of course, it goes in all directions too. And that's sketching complicated curves. Go down to day 1. It's way back here. They're going to ask for amplitude A, B, C, and D. A, B, C, and D. Some of these are pretty easy to get started with. And then work each of those. And we'll catch those negatives. Oh, let's do it right now. What if I had the sine of negative theta, or if I had the cosine of negative theta? Do you remember what the cosine of negative theta was? The same as? Same as without it. So if you see that negative, just remove it for cosine. And if you see it for sine, what do you do with the negative? Put it out in front. So that just give you that little hint on the homework.